Good afternoon. Um, this is there's kind of getting back into Max for Live, and what I'm going to do this afternoon, and I'm going to limit this, I think, to maybe sort of half an hour or so, just because it can get quite intensive. I'm going to start building a Max for Live device based on audio processing, and it's going to be made in several stages. So the idea is that I'm going to create a sample slicing device, which initially will be able to load audio into, see on a waveform on screen, see that we can select elements from the waveform and maybe work with sort of micro looping and reversing and stuff, pitch changing, to see what the potential is for what we can do. And then I'll extend that into a kind of live sample slicing tool that takes in audio from Ableton, processes it, and then sort of spits it out the other end. Yeah, that's the plan anyway. I'll periodically just jump across to the chat page in YouTube. There's probably a smart way of doing that, but I can't be bothered to think about what it is. Okay, just a real quick bit of revision then. I've looked at Max for Live exactly once in 2021, which was about 10 minutes ago. So I'm kind of revising for myself a little bit as well here. If you remember, there are 3 device types that you can create in Max for Live. There's an effects processor, an instrument, and a MIDI effect. I think for the sake of simplicity, I'll build this as an audio effect, because at this point I don't think I want to be able to have MIDI input, and later on I'm going to add an audio input. So I need to think a little bit about my kind of design process here. I've been encouraging people to try and start from the user interface and work backwards in terms of designing things. I haven't done that, but I can see in my head what it's going to look like. I'm going to have a sample waveform display and a kind of scrollable element on it to start with anyway, and then I'll perhaps extend that as I go on. So I'm going to dive in and create a new Max audio effect, and I'll put that on a blank audio track and just open up the editor and make that fairly large so we can hopefully see what's going on. And remembering that the way the editor works is it will drag in or pull in audio from Live, process it, and then put it back out through Live. So the audio engine is Live's audio engine, not Max's in that sense. Okay. What I'll do is start with a couple of objects designed to handle sort of audio, and in fact I'll start with the first and possibly most confusing part of this little process. Remember, to make a new object we need to be in edit mode, as in the patcher is unlocked, and we press N on the keyboard. So if you just see things appearing on the screen, I've just pressed N on my keyboard. Okay, so what we want to be able to do is load in, process and play back a chunk of audio in terms of the way DAWs work and the way DSP processing works, for example, or kind of any software process that requires rapid access to raw audio data for playback. We hold our audio in a small piece of memory in the computer, a small piece of RAM, or in the case of a DAW, we contain the audio on our hard drive or solid state drive, which is then pulled off the drive, stored in RAM for a bit, and then sent out to the digital to analog converter so you can hear it. That bit of memory is called a buffer, or is referred to as a buffer. And so in Mac's language, what we need to do before we can do anything else with our audio is make a buffer to store it in. And conveniently, the name of the object that we use to store audio in a buffer is called buffer, or I suppose more exactly it's called buffer tilde. Remember, when we make an object in the Mac's language, we normally need to provide the object with some arguments. So in the case of buffer, it says that I'm required to give it a name, and then after that I can provide it a file name, which is a direct link to a file perhaps on my hard drive that I want to load, and a duration, which is a number of milliseconds, and a number of channels. So if it's stereo, it'd be 2 channels, for example. All that other stuff is optional, so all I'm going to do is give the buffer an amusing name that's not too long, because I'll be typing it a fair few times. Let's call the buffer Crow. Just looked out my window and there's a crow out there. Okay, doesn't matter what you call it, it could be called anything. What we're going to do is refer back to that buffer by its name later on. Right. So let's think about this. What we need. So this is going to store our audio. What I also need is a way of playing it back. Well, there are a number of objects that refer back to the buffer and allow you to play back the audio. The best one, in my opinion, is called Groove. And it simply plays back the buffer in a loop. And it says here we need to provide a buffer name and the number of outputs. Okay, the buffer name is Crow. I'm going to assume that I'll be working in stereo. So I need to say Crow and then 2 for the number of outputs. And I also want to make an object that will display the contents of my buffer. And that object is called waveform. Now, when you make a waveform, it immediately turns into a graphical object, which is quite good because I want a graphical object. However, I can't now type in the buffer name. So what I must do is send it a message. It's M for message on the keyboard. I think the correct message is that we set the waveform's buffer reference using the set word, set message, and then type in the name. Find out if this is going to work in just a second. So what I did there was locked the patcher, tapped on the message to send the message to the waveform object. There's nothing in the buffer, so it's going to be blank at the moment. All right. Now I'll keep my plugin object up here for later on, because later on I'm going to demonstrate how to get audio in from live and process it. But for now, all I want to do is hear my my sound, which is going to play out of Groove. So we hook up the Groove to the plug out object. And then in a second, I'll go through how to get it to play back the sound. But we need a sound to work with. Okay, so how do we do that? All right. I'll demonstrate a quick and easy way to do this, but I also want to think about how my user is going to interact with this and how you might want to conveniently load in a sample from the live interface. So in the first instance, we can send the buffer object a message replace. Right, watch this. I'm going to lock my patcher, lock. I'm going to click on replace. It brings me up a file selector. Let's load a sample. I don't know if we can see this, but I can now see the contents of the buffer here, because the waveform object refers to crow, which is my buffer. Get the theme of buffers with bird names as we go on. So now the contents of my buffer is apparent here. It looks like it's got some music in it. Now I'm going to play it back. So to play it back, I need to tell Groove two things. I need to tell it to start, and it has a special message called start loop. We can see how when we type in commands into the empty message box here, that Mac sort of knows that there's a Groove object on the patcher and will help me out by telling me that there's a method here for starting audio in the Groove object. And if I press that, nothing. Now, there's a slightly confusing feature of Groove. Think about Groove as a record playing, hence Groove. What you need to do to as well as press the start button to get the record playing, what you need to do is tell it how fast to play. Which in terms of a record deck, you'd say set it to 33 or 45, whatever. With Groove, we send the Groove object a constant audio signal to tell it to go, and that audio signal comes from an object called sig. The default for sig, or the default for Groove, is if sig is 1, what will happen is probably will play straight away. There we go. What will happen is that the sample will play back at its natural default pitch. Right. We're doing a terrible job of explaining this, but let me just kind of revise what we've got here. This is buffer. Buffer holds a sample. The replace message provides us with a dialog box where we can load in a sample into buffer. This is waveform, where we've set waveform to the same buffer by using the same name. You probably wouldn't want to have multiple instances of buffers with the same name. That would be a bad idea. So that's now displaying the contents of the buffer, and then Groove is our playback object. It has a name that is also the buffer name, a number of channels, so 2 in this case, one for left, one for right, and then that goes to the output. And to get Groove working, we need to give it a constant value to tell it how fast to play back, and we need to send it a start loop message, and then it will start playing. I don't know how that is on the stream, but that in my ear is frighteningly loud. So I'm just going to turn the output on the channel there. There you go. Okay. I'm going to tackle a graphical nicety first. This is rubbish. This replace thing is terrible. If I want to load my device into Max for Live and then intuitively provide it with a sample to play back, I might need a different method to do that. My inclination is that we'd need a drag and drop interface. So we can just drag a clip or a sample or whatever into the device, and then it will play back. I'm going to use an object called live dot, I don't remember what it's called, live dot something, live dot drop, which provides a kind of blank region into which we can drop things. And I'm also going to put my waveform up here as well. So I won't work in presentation mode for the moment, but if I just save this device on the desktop for now, we'll see in the window down here that we can sort of start mucking around with how this works. So what this will do is it will output, well, what will it output? The path name of the dropped file, and it will output what it is. So I'm interested in where it is. I can't just send that to the buffer because the buffer is expecting something with the word replace in front of it. But what I can do is add a variable into the replace message, which we do by creating a variable with a $sign. So we can say replace and then a variable. And then when I send this to the message box, what should come out the other end should be, crossing my fingers because I've not tried this for a very long time, it should be the word replace and then the file name of the thing that I just dropped in there. The catch is I can't try that out from, I think I probably can try this out actually. Let's try this out from the Max editor. Let's find a new sound. Where was that? It was in there. Let's see, what happens if I drop that in there? Ah, and did you see that? My sample display has changed, and hopefully there we go. Let's try another one, just to make sure it's really working. Wonderful. Let's put my Lynn Collins break back in there. All right, that's cool. Now, I know how this behaves, which is when we're working inside live, as in with the editor closed. The way live.drop works is it allows you to drag and drop from the live browser and think from a track as well. So we should be able to drag a clip from a track, put it into my device, and work with it from there. But I'll leave that as it stands for now. All right. So I need to think about what my loop slicer is going to do. And I think one of the fundamental things here is that it will allow me to change the pitch of my loop to match the tempo of my track, which I know is functionality that already exists in Ableton, but I think being able to see how to do that and manipulate data in Max is probably quite useful. Okay. Before I do this, I need to understand how SIG works and what the playback's doing, and probably should also think about getting this looping. So we can make the Groove object loop, just play back within its own internal loop by sending it the message loop, and then either a 1 to make looping work or a 0 to make it stop, i.e. it's a variable and the loop message can be generated by using loop in a message box like that, and then using a toggle switch which will output a 0 or a 1. Let me show you what I mean. With loop off, the sample plays through once. The loop on, it will repeat. That makes sense. Now, what's SIG doing? Well, SIG says 1 is the default playback rate. Okay, so, which is cool. Now, what if SIG was 2? So if I type a 2 in here, now it's playing back at twice the speed. Now if I put in 0.5, now it's playing back at half the speed. Okay. What happens if I put in negative numbers? It goes backwards. So what I can do is perhaps make a number box like live.numbox, attach that to the SIG, and then have that operate as a speed control. Perhaps if I make it floating point output. Stop. So let's just dive into the inspector for this number box and say unit style is going to be float. And the range, well, by the time we get to... Actually, you know what, that's fine. Let's just leave that as it is. I think actually it'd be good if it went from minus 100 to 100. Let's see what that does. So we'll now go from super slow to ridiculously fast, forwards, and backwards. We'll put fine tuners on this. So one really fun, straight up useful function of Groove is that you can feed it a number that will get the audio to play at any rate you can possibly imagine, from almost imperceptibly slow to so fast it becomes its own waveform. Now the fact that it's a range of, well, nominally 1 is default, and then above that is fast and below that is slow. We can make use of that feature. What it's kind of saying is, as a relationship to the sample size itself, we can use SIG to define a ratio of how fast to play the sample based on its initial speed. So like, for example, if we put SIG as 2, we're kind of saying that we've got a ratio of 2 in relation to, or double in relation to the original playback speed. And we put 0.5, we've got a ratio of half. Now, I know that I can get the length of that sample as information in Max, and because I know what tempo is, I can get information about how long a bar lasts at a particular tempo, and I can use that information to manipulate SIG to make sure that Groove plays my loop at the appropriate tempo. But how? Let's do the first thing first. So if I want to find out how long my sample is, or I could look at this waveform display here, which goes from 0 to 20 something something, or I can use this object called info. And we can refer to our buffer with info, and then there's lots of outputs here, and we can see when we hover the mouse over, each one does a different thing. There's one over here somewhere, total time. Let's just read its output for now. And then to get info to actually spit out the data, we need to trigger it with something. So normally we could just put a button above here, and we can see that my crow, my sample, my buffer here has a length of whatever that number is. It's in milliseconds. Kind of really doesn't matter what the number is. It just has a length, and it's in milliseconds. Now, what if we could find out how long a bar lasted at the tempo that Ableton's set to? All right. How can we do that? Well, we can get the BPM, we can figure it out. There's an object called transport that does the same thing as info, but for kind of general transport settings in Live. And down here somewhere there'll be one for tempo. Okay. So that's the length of my sample. That's my current tempo, 153, is that right? Yeah. What relationship does this have with this? Well, the tempo's in beats per minute, isn't it? So that's and I know that this sample is 4 beats. It's a bar. So if at some stage I need to deal with how many bars there are in a minute. But let's take beats for a second. If I know that the tempo is beats per minute, I kind of know how long a beat actually lasts for, because I could perhaps time it, see how long it goes on for. It will last a finite amount of time. We'll put it this way: if your tempo is 60 beats per minute, that means in the space of a minute there are 60 beats. There are also 60 seconds in a minute, right? So it's 60 beats per minute. Each beat lasts for a second. And how do you get there? Well, you can divide one into the other. I'm going to do this in Max, so we can see how maths might work. So if I make a divide object, I'm putting a default number in here. We'll see what that is in a minute. And then I'm going to send that number. No, I'm not. I'm going to put in, actually, sorry, I don't know what I'm doing. Let's put in a number. Let's put in 60. And then let's plonk this number into the other side. Like that. So we divide our tempo into 60. Given that that's beats per minute, what that should do is give me a number that is how many minutes a beat lasts, which is interesting. It's 0.392 of a minute. I'm not really bothered about how many minutes a beat lasts. I want to know how many milliseconds a beat lasts. So, because a second is 60 times faster than a minute, and a millisecond is 1,000 times faster than that, we need to multiply this number here by 1,000. Trust me, this works. That number there is how long one beat lasts in milliseconds. How did I get there? I'm not even sure I can remember, but remember this rule of thumb. If you want to go from BPM to time, you take 60,000 and you divide it by the other one that you're going from. So if you go 60,000 divided by the BPM, what you'll get is a number in milliseconds that is how long a beat lasts. And if you go 60,000 divided by how long a beat lasts, what you'll get is the tempo. It's a kind of one of those triangular equations. Either way, that's a beat, that's a bar. So if I scale it up a bit, multiply it by 4, right? What I've then got is how long a bar lasts for. Again, kind of how much sense that maybe made. I just played back what I just said in my head, and I don't think I really understood what I just said. We could perhaps just accept this little bit of maths here. This 60,000 over your BPM multiplied by 4 is how long a bar lasts at that tempo. That is how long the sample is. And if I divide one by the other, what I'll get is a number that is the ratio of the original length of the sample and the actual length I want it to play at, which I can feed into SIG. See if that works. So make a new divide. We put that one in there and that one in there, and do that, and then press a few buttons. And I get a ratio of 1.34. Okay. Now if I press play on my groove object, the groove is playing at the correct tempo for the correct speed for that tempo. Look, if I push the tempo up a little bit, okay, there's a catch in that I have to press all these buttons again. Then the speed goes up, and that should match. There's a lag because there's a delay between the editor and the rest of Max, the rest of Ableton. Okay. Let's review, because I've just glanced away from the screen and glanced back at that, and it looks a little confusing. And I'll break this down into sections. So let's ignore that bit for now. Okay, the first bit is this bit. This loads a sound into my patch. And to do that, I use the object buffer and the message replace. This bit over here is purely for display at the moment. All that does is it shows me the contents of my buffer. This bit is playing back the sound. So we use the groove object, which refers to the same buffer by name. It's an arbitrary name that I've chosen. The SIG object sets the speed, start loop message makes it go, and loop with a 1 or a 0 turns looping on and off. This bit over here, which needs a little bit of work, this bit over here, that takes the length of the buffer and spits it out as a number in milliseconds. And then I've done some maths over here. And the maths is all about, let's get rid of that. The maths is all about how I can get the information about how long a bar lasts at my current tempo, given that there's a discrepancy between the a discrepancy between the length of a bar and the length of my sample, I can make use of that difference to control the speed at which Groove plays back. It's all in the interests of making a sample playback. Now, if what you're interested in is just playing back audio, perhaps you don't care whether or not it's at tempo. Perhaps what you're actually interested in is stuff around how you can lock things to a groove inside Ableton, in which case you need to know how to manipulate tempo and do stuff with it. Either way, that thing there, that rule of thumb thing there, which is 60,000 divided by your tempo, is a good rule of thumb to use. Another good use of that might be if you're working in the studio. Imagine that, working in the studio, and you've got one of those old school delay units where you set the delay in milliseconds, but you've got a tempo in Pro Tools. You can work out your delay time in milliseconds for your tempo. Or imagine that you were working in a large venue, and you wanted to work out how long it was going to take at a certain tempo, how long it was going to take sound to go from A to B. Actually, there's a rubbish example, but you get the idea. Okay. I guess the question is what now with this, and the answer is, there's a comment. Okay, let's just address this. So, a common mistake in Max is that we go, here's an object. Let's call a really common object like Metro, which does a click, and you give it an argument, which does. So it'll output a tick every 100 milliseconds. And then Metro takes a message. And the message, if I pull up this pop-up here, is, well, actually, it'll take a message to stop. It's really easy to do this. What I've done is tried to create an object and then typed in a name which is meant for a message, which might seem a little obscure, but this whole thing's obscure. Rather, what I need to do is make a new message box to type the message into. There's a distinction between what that is and what that is. There's this distinction between what that is and what that is. I suppose the other thing that we probably should address here is troubleshooting and trying to figure out whether or not things are working under the bonnet as they should do before we kind of think that maybe we've done something wrong. For example, let's say that Ableton, the track in Ableton was muted. Perhaps what I could do here is add a meter object. In fact, let's make it live friendly. Is add a live.meter here. That will show me that my object is making sound, even though perhaps I can't hear it. You know, maybe I've dropped my headphones in a bucket of water or something. So that's quite useful. And equally, I use these message boxes loads to look at what's happening in Apache, like I've done here. So you can make a message box, and if you send something to its right-hand inlet, like if I sent that to its right-hand inlet, I can look at what that message is doing. So here, when I turn on the switch, the actual message says loop 1, and when I turn it off, it says loop 0, because I've added this variable into the initial loop message. So I kind of creating a new message out of two other things and then seeing what it is. Other people like to use the console over here, which will give you information about potential problems in your patcher. Like I just made a new object called stop, and then let's try it again. Let's call another object crow. Immediately the console will go, that's not a thing. So it will tell me that there's an error. But also I can use the print object to print the results of what happens at a certain point on the patcher. And then there's a story as well. So perhaps as I change something, I can print it. You can even give the print an argument, like I could call that loop status, and then it will say loop status and then what the message is. So there's loads of different ways of kind of troubleshooting your patcher. Definitely a common, because the design isn't really particularly helpful, is it, in terms of, like, I don't know, it's not like you could say that MaxMSP is particularly friendly for those who are less adept at spelling, for example. It's not a hugely friendly environment, nor are most programming environments, unfortunately. But it does help. It does give you clues. I just want to wrap this up. I'm going to come back to this bit because it's messy at the moment, but it sort of works. I'm going to wrap this up with a bit more kind of exciting stuff around actually making the sound do something. Okay, so Groove has these two inputs for loop minimum and loop maximum, and Waveform has these two outputs here for selection start and selection end. So what I can do is connect those to the loop, and then I need to change how the waveform object behaves. So I need to change its selection mode. Is it that? Yeah. So I can select areas. Then, so okay, so just really quickly, I'm just do that again because that was a bit fast, wasn't it? There's a when you click on an object, there's this little pop-up arrow, and what you can do is use this to shortcut kind of ways of changing this object's behavior. In a way, it's the same as going to the information for the object and finding that mode. Here we go. We've got click mode here. It says select at the moment. I mean, if I set that to loop, we can see that slider there does the same thing. So it's a kind of like interactive way of changing the object's attributes in the inspector. At any rate, when it's in select mode, I can select areas of the waveform. And then if I get my sample looping, or you can hear what the results of that are. There's a great video in which Kieran Hebden well, didn't expect that to be the suggested search there. Somewhere where I can't actually find the video. I probably shouldn't play this because I'll just end up with my live stream being pulled apart because of copyright issues. But I'll just put this up on the screen here so you can see what it is. He breaks down his live set, and there's a little bit where he starts clicking like a maniac with the mouse. Here he is doing it. And on this video, he actually says, I could make a max patch or something to do this. But instead, he actually just clicks randomly with his mouse on the waveform selector in Cool Edit or something. SoundForge, one of those old school audio editors. But it has this sound, so it has this great kind of sort of glitchy, warpy kind of vibe going on. And I really like the way that this helps you kind of recreate that. Now, if I save and quit this, what I should have inside Ableton is the ability, okay, it's a right old mess at the moment, it's the ability to go and find a sound, drop it in there. I'm missing my, I can't actually press the button to make it go, but what I can do is select bits of it, and I'm sure that if I put my start loop and loop objects up here so I can actually interact with them, doing a really bad job of making a nice looking patch at the moment, but let's just do that. So put that in there, start looping, press these buttons maybe, does that work? Ooh. Like it. I think it's playing at a crazy high rate because it's a lot longer than 1 bar. So it's calibrated for a 1 bar loop. So I've made inroads into making this thing. I've spent far too long talking about this. So I'm going to stop the stream, and once I've just picked up on any final questions, I'm not sure how many folk are paying a whole lot of attention to this, but this will be here for you to look at anyway. Very quickly before I go, that's the right mess, isn't it? So what I've done there is made a patch that allows you to load in a sample, select an area on a waveform generator and play back the sound accordingly, but also set the playback speed of the sound according to a tempo derived from the live set. I'll expand on this next time,